This is the arrangements. This is what the Linux world primarily uses for names for all of the content. So I want you to see, remember the puzzle picture I was talking about where I could slide the squares around and I could figure out what the arrangements were? Look at these arrangements. So if you were looking at a picture that came off of these drives, and it came from this, so this is drive 0, drive 1, drive 2, blah, blah, blah. But this is now, think of it as a picture. This is that square. I'm looking at that segment. Let's say it's 64K, and I'm looking at that segment. This top row is going to be right if you have the right disk order. If all of your drives, if you put them all back together, and you're not dependent upon the parity slice, and you have those drives in the right order, this top row, the picture will actually be in order. Now the second row, the picture will be in order until you get to approximately where parity is, obviously, unless you're dependent upon that and you're using an application that calculates that. But I want you to look at the next one. This one's called left asynchronous. The next one is called left synchronous. You see the top row? It is the same. The layout is the same between those two. 1, 2, 3. See that? That's that slice that across the top that would be right. Now the second row is not right. If you look, they're different. 4, 5, 6, and then rotates to 7. And remember there was one of the pictures that had like a little blemish that was over here on the right later on in the lower row. It was in one of the earlier pictures I showed. It was a blue stripe across the top and had a blemish right here. Yeah. So that's where this parity, it hit that spot in that parity. So the row was actually right, then it corrected itself and it was parity. And then the next rows were wrong. Okay? And if you're looking at this, so if you look at the other rows, they will cycle back through. So once you get to the bottom of the cycle, they actually cycle back too. So on 4 drives, they'll actually cycle back through every 4th time. So your slice will repeat over and over. So you'll have a stripe that's good. The problem will be is that as the data shifts and the JPEG calculations are doing something with that, you might not have the colors right. So you might still see the stripe correct, but the color won't be right because it now has the wrong color tone for the stuff prior to it. Does that make sense? So when you're looking at this and you go back and forth between them, you'll actually see that those two have variations that will cause that problem. Now, here's the other thing. The next two. There's one called write asynchronous, and there's one called write synchronous. So all those things that you were scared of, with all those variations, there are 4 of these variations, but you will not see write synchronous or write asynchronous in any of the controllers. I have never